Today we'll explore AGENTS.md. It's a strong tool for making your work with Codex smoother and keeping projects consistent. You'll learn how to use this file to make your AI sessions smarter and faster. Let's look at our first main goal. First, you'll learn the main parts of an AGENTS.md file and what each section does. This basic knowledge helps you set up project rules clearly for Codex. Next, we'll look at the three levels of AGENTS.md files: global, project rules, and local. You'll see how they work together and how their order lets you control things precisely in any project. Once you know the structure, you'll learn to quickly make an AGENTS.md draft using the easy/init command. This gives you a great start, saving time and giving you a strong base for your project's rules. Finally, and most key, you'll build the habit of fixing things. Update AGENTS.md when you see repeated mistakes to stop them from happening again. This makes every future session smarter, teaching Codex and stopping errors before they start. You know what we'll do with AGENTS.md. To master it, let's first see the main problem it fixes and why it's a vital tool. We'll start by looking at how Codex works with your code. Remember, Codex doesn't save info from past sessions. It only uses the clear details you give it in your project. This means you control what info it uses when. This is why AGENTS.md is a must-have. It's like a lasting memory for your project. Every new session starts with all the key project knowledge ready. Think of it as giving Codex the basic info it needs every time. So AGENTS.md is a very useful tool. The rules, limits, and context you put in it work for all your project tasks. This makes every session you have with Codex smarter and faster, right from the start. You now see how useful AGENTS.md is as your project's memory. Let's look at what makes it strong. We'll explore the main content types you should add. So Codex always has the needed context. Let's start with your project stack. First is your project stack. Here, you'll list the main tech and tools your project uses, plus commands for tasks like running tests or starting your server. This helps Codex quickly understand your technical setup. Next, define your conventions. This part is key for noting your team's coding style, naming rules, component setup, and libraries you like for common tasks. Setting these guides helps keep your code base steady and clear. Your critical rules are just as important. Here, list the absolute must-nots, things to avoid, old methods, or repeated errors you want to stop for good. Stating these helps Codex guide you away from past problems and build a stronger base. Finally, add your main architecture decisions. Describe key design choices like data flow, how users log in, or how you use outside APIs. This keeps the system safe and helps Codex understand your project's base structure. We're starting with the agents.md file in our project. You can make it with the /init command. Codex will figure out the project type and the tech used. Codex also found the right commands to run the app and tests and the main conventions of this React project for consistency. The critical rules section is empty now on purpose. We'll fill it later. This is where you add your knowledge. You'll build this section over time, creating a memory for Claude based on your project's needs. We'll return to this later. Let's look at UI.md. This file sets the UI rules for the project, like layout and colors. You'll find details on border styles and transition times for interactive parts. The file also lists the app's component structure and steps for adding new ones. Now let's switch to datafetching.md to see data and state rules, starting with how our task objects look. This section shows tasks saving to local storage, using a lazy initializer for useState and a useEffects hook to keep states in sync. You can see main task actions like adding, toggling, and deleting tasks. These are passed as callbacks, along with the filtering logic. Finally, the doc lists what's still pending, like API calls or optimistic updates. We've seen what makes an agents.md file smarter for each session, how it becomes more precise and grows, but what if you need more control? What if rules apply to all projects or just parts of one? Codex gives you a strong 3-level system for your agents.md files, letting you manage its behavior with great flexibility. Let's start with the top level of control. First, you have your personal agents.md file. This global file found in your home folder holds your preferences and general coding style. It makes sure those rules apply to every project you work on. It's your main guide for how Codex handles your code. Next, at your project's root, you'll find the project's root's agents.md file. This file is for what's special about your current code. It's stack, rules, and critical rules that stop common projects mistakes. It makes sure Codex understands your current work's unique setup. Finally, for very detailed control, you can put subfolder /agents.md files inside specific subfolders. These files have rules that only apply to that project's path. This is great for handling different rules in, say, a front-end or back-end layer in a mono repo. This layering makes sure the most specific rules always come first, giving you full control. Moving from agents.md controls, we're now initializing Git in our projects before adding Codex. This command sets up our repository and makes an initial commit. Now we'll have Codex add a task completion sound effect. Codex is starting up, checking our project to grasp its structure and rules. I'm telling Codex to add a task completion sound effect. It should play a nice beep when a user marks a task as complete. Codex is processing the request, planning the sound effects, and starting by analyzing relevant files. Codex reports it will inspect the app structure and to-do state flow to wire the sound into the completion path. It has checked relevant files to get the context. Codex sees this is a Vite app with central to-do state in app.jsx. It will now read needed components and docs to ensure the change fits existing rules. Codex plans to use the Web Audio API in app.jsx for the sound. This ensures it's strong against unsupported browsers or test environments. The plan is to make a play completion sound helper and add it to toggle task. This ensures the sound plays only when a task goes from active to complete. A specific test will cover this. Codex made the code to play a simple sine tone beep using the Web Audio API and put it into the toggle task function in app.jsx. It also includes error handling for audio playback. Codex is checking task input.jsx and its CSS module. This is likely to ensure the new sound feature needs no changes or causes no issues. Codex sees a failing test for blank task input and will leave it alone. It will add a new test for the sound completion logic, mindful for the old failure. Codex added a new test to tasks.test.jsx. This checks if play completion sound is called and stops correctly when a task is marked complete, and not called when toggled back to active. The code and tests are ready. Codex is running the tests to find any syntax or behavior issues. It confirms the new sound test passed, but notes an existing unrelated test failure. After tests, Codex runs a static check with ESLint to ensure code quality, especially since the audio helper uses browser globals. Codex is now checking the final diff to sum up changes and highlights the remaining unrelated test failure. Codex successfully added the completion sound using the Web Audio API in app.jsx. It includes proper checks and a new test, linting, and the new sound test passed. The only remaining issue is the old blank input exercise. Let's look at code inside app.jsx. You can see audio values are hard-coded inside the components. I'm telling Codex to extract audio constants from the components into a separate utility file as good practice and then import them back. Codex is now working on the request to refactor audio constants into a utility file. Codex plans to move sound details to an audio utility, wiring task item to call it on task completion, and exploring relevant files including tests. Codex keeps checking the project structure and sound setup, getting ready for the refactor. Codex confirms the existing sound helper in app.jsx will move to source/utils/audio.js. Task items checkbox handler will trigger the sound at the instruction point. Codex implements the refactor, ensuring sound logic is in its new utility. You can see the code changes as Codex moves the web audio API setup and constants from app.jsx into the new audio.js file. Codex keeps working on the code changes, ensuring all sound logic is separate. Codex confirms the audio setup is now in audio.js, with task item importing the helper. It immediately runs lint and tests to check the refactor caused no issues. Tests run to ensure it works after the code changes. Lint and the refactored sound tests still pass. Codex is checking the final diff and git status before finishing this phase. Codex keeps its checks, ensuring the refactor is clean and the project state is right. Codex confirms the refactor is done, audio constants and playback logic are in audio.js. Task item imports play completion sound, and app.jsx now only handles task state changes. Checks confirm lint passed and the sound test still passes. It notes a known and related blank input test failure remains. Codex processes results and gets ready for the next instruction, ensuring the environment is stable. To prevent this issue, I'm telling Codex to update AGENTS.md with a new rule. Always extract magic numbers and config values into a dedicated utils file. Never hardcode them inside a component. Codex is now working on the instruction to add this new critical rule to the project's agents.md file. Codex confirms it will update project instructions in agents.md. This ensures future components work clearly follow this rule. Codex keeps preparing, checking the agents.md file to find the best section for the new rule. It finds the empty critical rule section perfect for this rule. This ensures it applies globally without disrupting existing course notes. Codex is applying changes to agents.md, integrating the new rule for magic numbers and config values. The updated agents.md now clearly includes the critical rule, always extracts magic numbers and configuration values into a dedicated source/utils/file. Never hardcode them inside a component. The new rule is now part of the project's guides, making future components work more consistent. I'll now manually check the change by running git diff agents.md to ensure the new rule is recorded correctly. Codex is running the diff command to show the changes in the agents.md file. The diff output clearly shows the new rule added to agents.md's critical rules section. We confirm the rule looks correct and is now a part of the project's coding standards. Now I'm committing all changes, the new sound effects, the utility refactor, and the updated agents.md rule with a clear commit message. Codex prepares to finalize these changes, bundling them into a single descriptive commit. Codex checks the stage states and pending changes, confirming they match the commit message. Codex ensures all parts of the change are correctly ready for the final commit. Codex clearly states the agent's rule, task item /app refactor, and utils file are all pending and will be in the next commit. Codex keeps preparing for the commit, ensuring all related files are included and ready. Staging fails due to sandbox read-write limits. Codex asks for permission to run the git add command outside the sandbox to fix this. I'm asked to confirm running the git add command, which will stage the project changes. After approving the git add command, Codex stages the changes and now asks for approval to run the git commit command with the message. I'm confirming the final commit, which will permanently record the new features and rules. After my approval, Codex commits all changes, the new sound effects, refactored utility, and updated agents.md rule. It confirms the working tree is clean. Codex performs a final status check, verifying the working tree is clean after the successful commit. The commit worked, and the working tree is clean. This ensures the new rule is used in all future sessions with Codex. As you keep fixing things, adding only the most key and repeated rules, your agents.md file will change a lot. It goes far past its first state to become something truly strong and special to your project. Let's see how that growth feels. The first draft from /init is just a start, right? But with every mistake you fix and rule you add, agents.md becomes a very precise and useful record of your project's growing best ways and collected insights. It literally gets smarter with every session. What's amazing is how this total knowledge gets built right into your code. This means any developer using Codex on your project instantly gains from all the past lessons and fixes you and your team made. It's built-in wisdom. Finally, see agents.md as more than just docs or a rulebook. It's vital project infrastructure, actively guiding and shaping every conversation you have with your AI assistant. It's the brain of your project's AI integration. We've explored agents.md deeply, seeing its role as vital project infrastructure that guides your AI assistants. Let's sum up that learning by quickly reviewing the main ideas we covered. We'll start by looking at what goes into your agents.md file. You now know what belongs inside your agents.md file. You can list the 4 key content types: project stack, conventions, critical rules, and architecture decisions. This structure ensures Codex always has the full context it needs. You also understand the strong 3-level system for detailed control. You can tell global, project root, and local agents.md files apart, and know how their order works. This gives you full flexibility across all your projects. Starting is also easy thanks to the /init command. You know how it automatically makes a first draft of agents.md from your code, saving you time. It's a great starting point for any new project. And most important, you've built the key habits of fixing things. You understand how powerful it is to update agents.md after repeated mistakes, turning short-term fixes into lasting project improvements. This habit will make every future session smarter than the last. This lecture deepens your understanding of Codex skills and how to leverage them for enhanced productivity. Let's cover our key objectives. First, you'll define a Codex skill and understand its crucial purpose in daily workflows. This foundational understanding sets the stage. Next, you'll distinguish between a skill and an agents.md rule, understanding their effective application. This distinction is key to choosing the right tool. Then you'll master creating a skill from a completed Codex workflow, turning past efforts into repeatable actions. Building on that, you'll discover how to invoke new skills explicitly or implicitly across current and future sessions. This flexibility ensures skills are always ready. Finally, you'll implement and use a reusable add article skill within our article showcase projects. This solidifies understanding and provides a powerful tool. Let's start with that foundational understanding. What exactly is a Codex skill? We'll build the definition step by step. At its core, a skill is a saved, named workflow Codex executes it on demand for repeatable tasks. Skills are simple markdown files typically stored in your project's .codex/skills directory for organization. Inside that file, you write a clear workflow description, including the exact steps Codex should follow without ambiguity. Think of the skill file as a consistent prompt template for Codex, key to repeatable, high-quality outputs every time you run it. Now, understanding skills for repeatable, high-quality outputs is crucial to distinguish them from agents.md rules. Effective application is key to mastering Codex and optimizing workflows. Let's examine their purpose. Agents.md rules constrain Codex's general behavior and define project context. Skills, conversely, enable specific reusable capabilities, giving Codex a new function to execute. Agents.md rules are always active, influencing every task. Skills, in contrast, are invoked on demand, explicitly by name or implicitly by task description. Scope differs. Rules establish global guidelines, patterns, or don'ts for your projects. Skills are specific, repeatable workflows stored in dedicated projects or global directories. Finally, rules act as guardrails, shaping how Codex operates and aligning with your project's vision. Skills are specialized tools providing new, powerful capabilities deployed precisely when needed. Our starting code is an article showcase project featuring a list of latest articles. You'll see 2 articles ready to view. Open the first article to scroll through its text, then return. Now let's view the second article. Observe the context display and easy return to the overview. We're back at the main article list. Download and familiarize yourself with the starter code. We'll use it to implement your first Codex skill. With the starter code setup and projects familiar, let's outline the add article skill workflow. It helps you easily add new articles. Here are the Codex's precise steps. First, Codex needs to research the given topic, gathering accurate, up-to-date information suitable for a general audience. After research, Codex writes the article content, a short 200 to 250 words article with a clear title and well-structured content. Codex must understand our project's articles.js data structure. It reads the file to identify required fields: ID, title, summary, content, author, and date. Finally, with this understanding and new content, Codex will add a new article object directly to your articles.js file, ensuring it matches the existing articles pattern. Before continuing, set up your project, git init, git add, then commit. This ensures version control. Before creating a skill, we'll perform the workflow manually once to have a concrete example to save. Let's ask Codex to add a third article now by typing the command. Watch as Codex begins. It inspects the project directory, reads existing articles, and understands the data structure, including ID, title, summary, content, author, and date. Next, Codex actively searches the web for accurate, up-to-date information on black hole formation, gathering content suitable for a general audience. Codex processes gathering information, confirms the article's data structure, and prepares content. It then adds a new article entry that perfectly matches the existing pattern. Codex writes the new article content into the articles.js file, ensuring correct structure and length. It then runs quick validation checks for data cleanliness. With the article added, Codex verifies content length and past lint rules. It also lists the reliable research sources used. The new article immediately appears in our application, seamlessly integrated into your latest articles list, fitting perfectly with existing articles. Click Read Article to view the full contents of the new How Black Holes Are Formed entry. After reviewing, easily navigates back to the main article list. Instead of manually repeating this process, let's save it. Here's how to turn what Codex just did into a reusable skill. We're telling Codex to store this skill locally within our projects folder, not globally. Codex is processing your skill creation request, evaluating the previous workflow. Codex automatically begins creating the skill. It uses internal skill creator instructions, evaluating the workflow to encapsulate it into a reusable function, ensuring project setup for local skills. It then explores the projects.codex directory structure, listing OpenAI.yaml and scripts to understand the current setup. Codex knows the .codex directory doesn't exist, so it prepares to generate the necessary skill files and metadata locally. Codex is creating the local skill path for the projects. The helper script is invoked via Python to ensure project local skill creation without modifying global files. The system is executing the helper script to create the skill directory. Creating the .codex directory is blocked by the sandbox, so Codex requests approval for the initializer command. Codex is awaiting your decision to proceed with creating the project local skill folder. You can see the exact command Codex wants to run. Review this prompt to decide if you want to proceed. Upon your approval, Codex successfully runs the initialization command, creating the add article skill and confirming its immediate validity. Codex is exploring the new skills files to prepare for customizing the templates. It explains it's replacing the generic template with a focused workflow tailored to our specific article creation needs. Observe as Codex applies a patch to skill.md, meticulously defining each step for the add article workflow, from choosing the next ID to validating word count and lint results. Codex presents the proposed changes to the skill definition, asking for your confirmation to proceed with these edits. After your approval, Codex confirms the successful application of edits, showing the updated add article skill workflow in skill.md. You are given a final opportunity to review the last edits to the skills workflow before permanent application. Codex is applying the final workflow refinements to the skill. With all edits applied, Codex performs a quick validation of the skill folder and its files. A git diff confirms no extra changes. Git status shows the new .codex directory containing our skill files ready to be committed. Codex is performing final internal checks after creating the skill. The project local add article skill is successfully created with UI metadata defining the workflow to research, write, and add articles. It's ready to streamline article creation. This is the content of our new skill. Notice Codex created the skill.md file inside the add article folder. You'll see a clear description of the skill's function, expected input, and the exact steps Codex follows upon invocation. Specifically, it researches a topic, writes an article, and adds it to the articles.js file following a defined structure. As a markdown file, you can directly open and refine these steps in your editor to customize behavior. Codex also created a second file alongside skill.md, agents/openai.yaml. Open it to see the machine-readable interface definition, display name, short description, and the default prompt showing add article invocation. While skill.md defines what and how, this file defines how Codex surfaces and invokes the skill. Rarely edited, its presence is crucial. With our add article skill defined and files in place, commit these changes, stage all new and modified files, then commit indicating the new skills addition. Understanding your skill's internal workings, let's explore its use. You have several powerful ways to invoke skills in Codex to automate workflows. We'll start with the first method. The most direct way to invoke a skill is using the /skills/ command, followed by its name, like /skills add article. This guarantees explicit invocation, telling Codex precisely which skill to run. For quicker, more convenient explicit invocation, use the $ shorthand. Simply type $ followed by the skill's name, such as $add article. This provides the same guaranteed invocation as the / command with fewer keystrokes. Finally, invoke skills implicitly by describing your task. Codex analyzes your request, automatically recognizing and using a matching saved skill, while natural, explicit methods offer more reliably when a specific skill must run. Let's explicitly invoke the add article skill using the $ shorthand. Feel free to try the other methods. Codex is now processing your request to create an article on the science of habit formation. Codex is outlining its plan, inspects data structure, verify scientific facts, append the new article, then validates its word counts and linting. First, Codex explores the skill.md file to understand the workflow and expected data structure for the article. Codex then reads the existing articles.js file to understand the current structure and verify no changes have been made to the data file yet. Now, Codex begins researching the science of habit formation, starting with authoritative sources on habit formation neuroscience. The search continues, including many relevant sources. Codex has completed web research, finding relevant articles to inform the new content. Based on its research, Codex determined the next article ID and current date, ensuring consistency with existing articles and grounding content in habit research. The AI drafted the article content, now being added to the articles.js file. This new content details the science of habit formation. After appending the article, Codex automatically checks the content's word count and runs linting to ensure project standards adherence. Word count and linting checks passed, Codex confirms the article's addition and lists all scholarly sources used for its creation. Finally, observe the results in the web application. The new article, The Science of Habit Formation, is successfully added to our list. Clicking it reveals the full content generated by the skill. Our add article skill has successfully added the article. Let's now commit these changes, staging all modified files and documenting this new skill's contribution in our commit message. Having seen skills in action, you might wonder when to use them. Deciding whether to create a skill for a workflow is key to leveraging Codex effectively. Let's explore good and poor candidates. Good candidates for skill creation are highly repeatable tasks, adding new pages or components, running a consistent release checklist, or creating structured content like the articles we just added. Conversely, one-off tasks are poor candidates, as are workflows that change significantly each time. You also won't need a skill for simple operations already handled by a project-wide agents.md rule. Crucially, agents.md rules are always on guardrails constraining Codex's behavior across all tasks. Skills, however, enable specific capabilities on demand, providing powerful, reusable workflows when needed. You've explored when and why to use skills. To solidify understanding, let's review key lecture concepts, starting with the fundamental skill definition. First, you understand a skill is a powerful, reusable workflow named and stored as a markdown file. This ensures Codex executes tasks consistently upon invocation, saving repeated steps. Next, you distinguish between a skill and an agents.md rule. Agents.md rules act as continuous guardrails for Codex behavior, while skills offer specific on-demand capabilities. You also mastered skill creation, seeing how effortlessly Codex can save a completed workflow, transforming it into a personalized, reusable template for future use. You're proficient in invoking skills, whether explicitly via commands like /skills or the $shorthand, or implicitly by describing your task in natural language. You have multiple ways to leverage saved workflows. Finally, you understand when to deploy these tools. Skills are ideal for repetitive tasks with predictable structures, ultimately saving significant time and effort in future development sessions.
Thanks for watching. If you like this, you'll love Zenva Academy. 300 courses where you learn AI by building real apps. Links in the description.